All right, hello and welcome to lab number 14, Cryptography Concepts. First of all, before we start, let me apologize because I do sound pretty bad right now, and if you bear with me, we shall get through this pretty quickly. Or not quickly, but quick enough. So in this lab, we will be conducting a stenography techniques using various tools. We will be hiding a message within a picture, hiding multiple files within an image file, hiding a text file within an audio file, and observing the avalanche effect on the hash functions. I may pause the video here and there just so I can cough and, you know, not blow your eardrums out. Okay, so let's get started. So the first thing we're going to do is we're going to go ahead and log into Kali, and the password and login information is Kali and Kali. We're going to go ahead and make our way to the steg file right here. And what steg is basically a stenography program capable of hiding data in various variety of image and audio files. And so once we open this file right here, we're going to go ahead and open the terminal. And so the first thing we do is we're going to make a file with echo and the secret password. I'm pretty sure it's not secret, but that's what I've always been putting. Oops. Okay, yeah, it's not secret. So let me keep it the same. The password to the when s is LDG LabPass 123. And we're going to go ahead and make that into the secret text. And so now to confirm that we actually did make this file, we're going to go ahead and concatenate, which is on the cat secret.txt. And as you can see, this is what came up. The password to the WinOS is LDG LabPass123 exclamation point. And so the next thing we're going to do is we're going to verify the capacity in the top secret JPEG image file, and we need to verify that just to make sure we have enough space so we can embed the secret text file. And to do that, we're going to go ahead and use one of the steg commands, and that is steg hide info top secret.jpg. Okay, so as you can see, the format is JPEG and has a capacity of 119.1 kilobytes. And we don't need any information about the embedded data because we haven't embedded anything yet. Okay. And the next thing we're going to do is we need to make sure that the secret file or the secret text is able to fit inside the top secret JPEG image file. So in order to do that, we're going to go ahead and du secret.txt. And as you can see, 44. So we have plenty of space to hide the secret file inside the JPEG. And so another thing what I'm going to show you right now is the hash values. And it should all these hash values should all be a unique value. And it's a unique value just so it shows you that the data has not been compromised in any way, shape, or form. And when the data has been changed in any way, shape, or form, the hash values flip in a way, I guess, or it's a bit flip, and that just basically shows you that the data has been altered, and that is called the avalanche effect. And you want a substantial avalanche effect because that shows you that the algorithm has good randomization. Okay, so we're going to go ahead and show you the hash values on the JPEG file. So oops, top secret.jpg. Damn it. Okay, so we're going to just leave this right now. We're going to compare it once we embed the secret file. Okay, so we're going to go ahead and use one of the steghide commands, steghide embed cover file, top secret.jpg, and the embedded file, which is going to be the secret file. And secret. Pop, pop, pop. Okay, so once we did that, we're going to go ahead and bring up the hash value again, and you're going to see what I mean with the avalanche effect. Okay, and as you can see, it is greatly different, and that's good. That's really what you want, because this shows you that this JPEG file has been altered. Or I should have put it better, the integrity has been lost in the stenography process due to a different hash value, and this is what this is basically. And so now we're going to pull up the information again, and I'm going to show you the embedded file. Steghide info secret. I don't know why I keep pressing H. Okay. And we're going to go ahead and press yes because we want to see the information. Secret. And as you can see, this is what comes up. The embedded file is the secret.txt, the size, and it's compressed. Okay. So the next thing we're going to do is we're going to remove this. We're going to remove the secret text file from our list, or from our list of files. Okay. So we're going to go rm secret.txt. Okay. So we're going to go ahead and list, and as you can see, we successfully removed the secret text file. Now we're going to go ahead and extract that secret file again, or not again, we're going to extract that secret file that was embedded within the top secret JPEG image file. Okay, so steg hide extract stego file top secret JPEG. Gonna do that. Okay, as you can see, we successfully extracted the data to the secret.txt file. And to show you that we do have the file, yes, you can see it's back, and now we're going to see the contents of that file with secret.txt. And as you can see, it's exactly the same. So now we're going to move on to the second objective, which is hiding multiple files within an image file. Okay, so the first thing we need to do is we're going to need to use the basic Linux command to hide zipped archives. Okay, so now I'm going to show you again the list, and as you can see, these are the top three, or not top three, these are the files within our list home. Okay, so now what we're going to do is we're going to create a zipped archive name called secret files, and we're going to include the files secret.txt and the top secret.jpg. Okay, so in order to do that, we need to create the zip file first. Okay, so we've successfully added that to the archive file, and we're going to go ahead and list the files in the directory. As you can see, here's our archive.zip file right here. So now we're going to do something different with the concate command, and this is the first time I believe I've seen this done. I haven't done this in any of my other classes, but this is really cool. Or at least I think it's pretty cool. We're gonna concate it. So we're gonna use the cat command to hide the zipped archive within the image file called CyberMonday.jpg, and this will enable the cat command to concatenate the image and the zip file together in a new file not named cybersec.jpg. And so we're going to go ahead and do that right now with cat CyberMonday.jpg. Okay, and we've successfully done that, and I'm going to show you right now with our listing of the directory. Okay, and here it is. And we're also going to see, or we're going to take note of the size of this. So from the original, or not from the original actually, I'm sorry. We're going to move on. Okay, so the next thing we're going to do is we're going to show the avalanche effect in all its glory. And I'm gonna give a more detailed explanation on what it is. Excuse me. So the avalanche effect is observed in cryptography when one bit in the plain text flips. The encrypted text will have at least half of the bits flipped. And in contrast, if the avalanche effect does not exist or is not so significant, it means the encryption algorithm has poor randomization, or in other words, it is less secure. And so in this section, we will observe the bit flips in the MD5 hash function in a popular tool called CyberChef. So we're going to go ahead and just minimize this. Minimize this. And where is... over here, sorry. We're going to go to downloads, and we're going to go with CyberChef, open folder, and we're going to go ahead and open the web browser. Excuse me. Okay, so this is actually pretty cool, or at least I think it's pretty cool. So I'm going to break it down into sections. This is section 1, this is section 2, section 3, and section 4. And number 1 indicates the recipe or the function search field. Number 2 is the main operation field, where the recipe function can be added to apply the algorithms, which I'll show you right now. And number 3 is the place is the place that accepts user input, and number 4 is where the output of the result will be. Okay, so the first thing we need to add is from binary, and we're going to go ahead and double click on that. And the next thing we're going to do is MD5. Okay, and the last thing we're going to do from binary to binary, back to binary. I don't know why that's not coming up. That is very odd. Okay. Yeah, I'm not sure why it is not popping. Wow. Actually had a space in front, so I believe that's why it was not popping up. embarrassing. Okay, so right now we're going to enter the binary form of the word secret. And we're going to go ahead and put that in the input right here. And we're going to include all the spaces. One, okay. So now we're going to go ahead and copy this. I'll just put it right here. Or not. Okay, text editor. Okay. And we're just going to leave it as that. In the example, it wants us to space it out and make it look better, but I'm going to just leave it like that just so you can see how the bit flips happen, or you can see where the bit flips. It's just easier to kind of visualize in a sense. Close that. Okay. So now we're just going to bit flip right here, and as you can see, just with this one bit flip, it's going to change the entire output, and that's exactly what you want. That's the avalanche effect. And it's really hard to kind of notice right here. It happens really fast, but you'll see it right now. Okay, so now let's take our time to compare it. As you can see, all the bit flips. And that's what you want. You want, generally speaking, you want more than 50% of the 50% of it to flip. And that shows that it's good randomization. Okay? And that concludes lab number 14, cryptography concepts. And hopefully my voice did not make it too bad, but have a good night.